The three questions that I had to solve for the final exam review is question 2, question 7, and question 14. I'm going to be starting with question 2. The question says, graph the transformation of the square root function f of x equals 5 minus the square root of negative 1 minus x. The question also says to give the coordinates of at least 3 points labeled on your graph. I find graphing pretty straightforward. The easiest way that I do it is build a table of values. This is my x values and this is my y values. Now, I went ahead and played with a couple numbers before I found that these three numbers would give me 3 whole numbers for the value of y, so I am able to graph it easily. The first value that I took was negative 10. So I just took the same equation, f of x equals 5 minus the square root of negative 1 minus negative 10. The y value is 2. The next one was 5 minus the square root of negative 1 minus negative 2. The y value is 4. 5 minus the square root of negative 1 minus negative 1, and the y value is 5. So for my x values, negative 10, negative 2, and 5, I got 2, 4, and 5. As you can see on this graph, when x is negative 1, my y value is 5. When x is negative 2, my y value is 4. And when x is negative 10, my y value is 2. This graph is the square root function, and as you can see, it is going to the left forever. The next question says, apply Cramer's rule to solve the following system of equations for the exact value of z only. Cramer's rule must be used to receive any credit. Note that the following determinant is provided for your own convenience. Now, in the question, we were provided the determinant, which made it a little easier to solve. This is the system of equations. It is in the form of a1x, b1y, and c1z. a2x, b1y, b2y, and c2z. a3x, b2y, and c3z. So it's in the value of a1, a2, a3, b1, b2, b3, and c1, c2, c3. These values will be known as d1, d2, and d3, based on the formula that we've learned in this class. Now, like I said earlier, we've already been given the determinant, so we don't need to solve for that. To get the value of z, it would be dz over d. And to get dz, what I would take is the values of a1, a2, a3, b1, b2, b3, and instead of c1z, c2z, and c3z, we're going to be taking d1, d2, and d3. This matrix is the exact values for these numbers in the system of equations. Now, what I'm going to be doing is we're going to take the value of a1, and since it's in the first row and the first column, we'll be taking these 4 numbers, which is b2, d2, b3, d3. And as you can see here, I put them in a matrix and I have cross multiplied them. So 1 times 4 and 1 times negative 2 minus negative 3, which is going to be the value of b1. And since it is in the second row, first column, we're going to be taking the values of a2 and a3, d2 and d3. So we're going to be taking this value, this value, this value, and that one. What I did is I cross multiplied them, 1 times 4 and 1 times 1, plus the value of d1. And since d1 is in the third row and first column, we'll be taking the values of a2, a3, and b2, b3, since this will cancel out this row and it'll cancel out that column. Now what I've done is the same thing. I have cross multiplied the values in the matrix, and here I've just expanded what I've multiplied. So we get 4, 1 times 4 is 4, minus 1 times negative 2 is negative 2, plus negative times negative is positive, that's where I got the plus 3 from. And then 1 times 4 is 4, 1 times 1 is 1, 4 minus 1 plus 13, 1 times negative 2 is negative 2, and 1 minus 1 times 1 is 1. I get 6, 4 plus, this becomes negative times negative is positive, so I have a 6 over there. 6 plus 4 minus 1 is 3, 3 times 3 is 9, minus negative 2 minus 1 is negative 3, 13 times negative 3 is negative 39, and my final value is 24. Now, as I've mentioned earlier, z equals dz over d, and negative 24 is the value of dz, and negative 10 was our determinant given to us in the problem. Now, this can be simplified by dividing by 2. Negative 24 divided by 2 is 12, and negative 10 is divided by 2 is 5. So this is our final value of dz. The third problem, number 14, asks to show that these matrices are inverses of each other. So we're given the value of matrix A, which is negative 4, 7, negative 1, 3. And in the problem, it says B equals this inverse value, but I prefer to write it as A inverse. And the inverse that we're given is negative 1 over 5, and matrix 3, negative 7, 1, negative 4. Now this is the inverse formula that we've been given in this class, which is 1 over AD minus BC, and then the matrix D, negative B, negative CA. Now what I've done is simply just taken out the variables and input the numbers. So I have A equals 1 over negative 4, which is the value of A, 3, which is the value of D, minus 7, which is, the minus is part of the equation, the formula, but 7 is the value of B, and negative 1 is the value of C. And all I've done is just input it into the formula. And then this matrix is given in the form A, B, C, and D, so we'd have to go back and put it in this form because of the formula. And so we get 3, which is the value of D, negative 7, which is the value of B, negative 1, which is the value of negative C, and 3, which is the value of A. Now once you simplify this, you will get 1 over negative 5, and just rewrite the matrix. Now I've watched some YouTube videos to further simplify this and ensure that the inverse that we've been given is correct. And one way that I've learned that we can do that is multiply matrix A by its inverse. And if we do that, we'd have to get the form of the matrix being 1, 0, 0, 1. Now in order to do that, what I've done here is I've multiplied matrix A, which was negative 4, 7, negative 1, and 3, and A inverse of 1. Now you see these fractions simply because I've taken this negative 1 over 5 and distributed it into the matrix. So negative 1 over 5 times 3 is negative 3 over 5. Negative 1 over 5 times 7 is 7/5. Negative 1 over 5 is negative 1 over 5. And negative 1 over 5 times 3 is 4 over 5. Now I have multiplied the values in matrix A by the values in matrix A inverse, and I've gotten 1, 0, 0, 1. And going back to this rule, it is visible that this value is the inverse of A. So B is the inverse of A.